you're seeing my screen, you see write the expression as a single power, only using positive exponents.
Yep.
So when the bases are the same, which they are here, and you're dividing, which you are here, you subtract the exponents.
Yes.
Okay. So it can be written like this: x minus 6 minus 4. So this is x to the minus 10 power.
Yes,
But
it can't be a negative.
right. So we're using the property that x to the minus n equals 1 over x to the n. Essentially, you put a 1 over x, and then whatever this number is, which happens to be 10, down here it becomes positive. So negative 10 becomes positive 10. So question number 2 here, I'm going to snip in. I'll just point out that when you have negative exponents, it never changes the sign alone. So like just because it's negative has nothing to do with like these negative answers are ridiculous. Okay, they just it doesn't it's not a multiplier, it's a power. So there's several things you could do here. One of the problems is that order of operations. There's really no precedent here. So you don't like everything kind of could be done in any order. Like 2 over 4 inside here is really 1/2. Okay. So more generally, when you have a over b to the negative n power, you flip what's inside. Bottom goes to top, top goes to bottom, and it goes to a positive exponent.
Okay.
So if you flip what's inside here, what would that be?
It'll be 4 over 2.
Or 2 over 1 to the power of. Now you said 4 over 2, and that's fine. That is fine as well.
But you have to reduce it.
Well, you don't have to. You actually can apply the exponent to both of these. Now, by reducing it, it makes it faster. Like you'll see that the answer is 2 cubed over 1 cubed. 1 to any power is always 1. So this becomes 8. Now we should get the same thing over here. 4 to the power of 3 is 4 times 4 times 4. That's 64. 2 to the power of 3 is 2 times 2 times 2. That's 8. Do you see how this equals 8?
Yes.
Okay. All right, so question 3 is kind of more intense here. It's got a lot more going on. Okay, assume no denominator equals 0. Okay, I have no idea why that's saying that. All right, so there's a bunch of things here.
That are going on. So 8 to the 0 power is going to just be 1.
That's right. So that you almost don't even need to write that because 1 times anything is 1. So I see t to the 6th over t squared, w over w to the 4th, u to the 6th over u to the 6th. Like there's 3 separate things, and then this
Yes.
8 to the 0. So you already said that that's 1. Great.
Mm-hmm.
What is t to the 6th over t to the 2nd?
T to the 3rd power. Oh, 4. Sorry, I forgot.
When the bases are the same, say this out loud or write this down. Bases are the same, and you're dividing. You subtract the exponents.
The bases are the same. You're dividing the subtract the exponents.
Right. So this is really it's like 4 separate parts of a question. You already did the first 2. So now the next one is w to the 1 minus 4 power,
which is -3.
So it's t to the 4th, w to the -3. Then this is u to the 6 minus 6 power. What is that?
0.
Okay, so u to the 0. What is u to the 0?
1.
1. So this is 1. That's 1. So if you get to this step here, you see that it's t to the 4th, w to the -3. How can we rewrite w to the -3?
1 over w to the 3rd power.
Okay, and then what does this simplify to become?
T to the 4th over w to the 3rd power.
All right. Okay, so I want you to try the next one on your own here. I don't know if you have it pulled up or not, so I'm just gonna do this. I'm gonna step away for 60 seconds because I gotta grab some food. But
Okay.
I'll say hello when I'm back.
All right.
All right, Christopher, I'm back. Do you have an answer for this?
A to the 12th power over 11 to the 20th power.
That's right. This one right here.
Yes.
All right, very good. So you're just applying a previous rule. Okay, so the last question here. This is the synthesis question. This is the one where they're hoping that if you understood everything else, that you'll be able to do this one. Like I mentioned earlier, you have a choice here. You can either simplify inside the parentheses first,
Or outside.
yeah, or you can apply the exponent. Now you have to do both. It's not like one gets rid of the
Or
other,
the other.
but I would do what's inside parentheses first.
Okay.
If you don't want to do that, that's okay too.
Well, I usually just go to. I know how to do that, but I would like to see how to do it.
Okay, so inside parentheses you have 3 g over g to the 5th h to the 4th over h squared. Okay, so you have 3 things here. There's nothing to do with the 3.
So just by itself.
Yep. So what about this g to the 1 over g to the 5th?
That'll be g to the negative 1.
Okay. How about this h to the 4th over h squared?
That'll be h to the power of 2.
So how do we rewrite this on the inside parentheses?
What we would have to do is g would be 1 over g to the 4th power times 3 times h to the 2nd power.
So this simplifies to 3h squared over g to the 4th, all to the 4th power.
Okay.
So now what you've assured yourself is all you have to do is apply this 4 to each of these exponents and multiply them.
Yes.
So that's 3 to the 4th, h to the what power?
To the 8th power.
And then g to the 16th power.
Yes.
3 to the 4th is?
81.
81. So the answer is 81 h to the 8th, g to the 16th power. So it looks like it's
the third one.
The third one again. All right. Was there any of those you'd like me to go over again?
Nope.
Okay, so we're going to submit. All right. So, I mean, interestingly, these are considered quizzes.
Yeah.
I don't know. It's
just the homework mainly. It's
all right. Now you can't see my screen, but I'm
well, I can see the last question that we did. So
yeah. So we're moving on here to scientific notation. All right, I'm gonna grab the question and then we're gonna work on it here together.
Okay.
All right, so write this number in scientific notation. So the first thing you have to do is figure out where the decimal point is. Decimal point is right there,
It's
right?
always at the end, or it can be in front. It
Yeah, it
depends.
depends on the problem. So I'm having some issues here. All right,
You're starting to glitch out for me.
should be okay now.
It's starting to get better.
The first thing to do is to count the number of places that you need to move the number. So the scientific number in scientific notation has two parts. It has a number times 10 to an exponent.
Hmm.
So this number has to be between 1 and 10.
Yes.
So you move the decimal until you get a number between 1 and 10. So you go 1, 2, 3, 4, 5, 6, 7.
Hmm.
So the number of times you move it tells you the exponents. So it's either 7 or minus 7. And we can talk about that. The number that's left over is 3.6. So this is 3.6 times 10 to the seventh. Okay. Now
Hmm.
why now there's all these rules that books have, like, well, if you move left it's positive, and if you move right it's negative, and uh like,
That's the opposite, though.
well, you have to come up with what you think is what you however you want to learn this. Like, it's not, I don't think these rules are helpful. I think it's easier to make a decision based on your answer here.
Hmm.
Okay. And to me, when I look at this number, I know that I'm going right with the decimal. So I'm going to get back to a large number like this.
Yeah.
So now they have you go the other way. They have you in the next question here. You have to you take a small number. I'm sorry. They give you a number, and so previously we took a number that's in I don't know, we'll call it standard form,
Okay.
and then they wanted you to go to scientific notation.
Hmm.
Now we're going from scientific notation back to standard form.
Okay.
5.66 times 10 to the eighth. So that means you're going to move you're going to move it 8 times. 1, 2,
But I
3,
just
4, 5, 6, 7, 8. And then you've got to put zeros in those missing positions, and that's where your new decimal goes.
Mhm.
So then there's commas. The commas really help for readability. You can either put lines in as well.
Mhm.
So this is 566,000. I'm sorry,
Five
500
hundred sixty-six million.
million dollars, as our buddy Dr. Evil would say. Okay. All right. Oh, this is interesting. So this is the first first one where you actually have to enter in a value.
Which question is that?
Number 3.
Oh yeah, number 3 and 4. I did not know how to do this.
So again, you start by writing the number.
Mhm.
Okay. Now, -4, that means you're either moving 4 right or 4 left.
In this case, we're gonna move 4 left.
So you go 1, 2, 3, 4, and you put a decimal there.
Mhm.
You fill in those positions with zeros.
Yeah, and I didn't understand what they wanted. I didn't understand what the next part was that they wanted me to do.
So they're saying, okay, this means put a 0 before the decimal, so you have to go 0 point, because that's this 0. 1, 2, 3 zeros, 8, 4, 2. So when you're doing these online formats, you have to know how to enter the answer.
Mhm.
All right, so I'm going to ask you to do the next one on your own, and you're going to tell me verbally what we're gonna enter into the answer space. So take as much time as you need. I'll be here. I'm just going to mute myself while I snack.
Okay.
All right, so let me work through this problem, and you can tell me if your steps are the same. So first thing you're gonna do is write the number. Then when I say number, I mean the part in front of this. Now -1 either means one left or one right. In this case, it's left. So you go left one, you put the decimal there, 0 in front, 0.686. Is that what you got?
Zero, but I got the 0.686. Just forgot that.
So the only reason you got to put a 0 in there is because it tells you that when you're entering it, not because of not because of anything else. So this next question is actually it's actually a really good standardized test question. Whenever you have to sort things, and I don't have any of these in my questions, but these are good to have here. To order from least to greatest. So we're really, the first thing to do is to look at the exponents. You got 10 to the 21, 10 squared, 10 to the 21, 10 squared, 10 to the 12. Which is the biggest exponent? I can't hear you. I can't hear you.
The 8.8 and the 2.8 don't matter in this case.
They do, but we're making like a first. It's like making piles. It's like first you make a pile of le, you make a pile of Legos that are big pieces, small pieces, medium pieces, and then you go into them and look at them. So uh, the smallest exponent is the 2. We're starting with this. So we have 6.2 times 10 squared, 1.5 times 10 squared. Then we have 5.1 times 10 to the 12th, 8.8 times 10 to the 21, and 2.8 times 10 to the 21. So this is from least to greatest. Do you see how I group these by exponent?
Yes.
Okay. Now between these two, you have to decide which is smaller and which is bigger.
1.5 would be the smallest.
That's right. So 1.5 times 10 squared, comma, 6.2 times 10 squared. Now let's look at, and then you definitely have this 5.1 times 10 to the 12th. Now between these, which is bigger, which is smaller?
Uh, the smaller one is 2.8.
Very good. So let's see if we can find it over here. There's a lot of numbers, so it would be okay if looks like this is correct. Okay. Any questions on that?
Nope.
All right. It's kind of like that last problem. Maybe we'll see it again on the quiz.
Okay.
Let's go back to grades. So we're up to Wednesday's work. Do you remember reading anything in your syllabus about whether calculators are allowed or?
Yeah, you can use calculators.
Okay. This is the one part of the class where you kind of need to be using a calculator to get the full benefit of what you're trying to do.
Yeah.
The problem is though is that you just get an answer, so it doesn't really help. Besides your phone, do you have another calculator available to you?
I want to say no.
There should be one in the office in that small.
Yeah, I think so.
Can you go grab it?
Sure. Give me a minute.
All right. Do you have the calculator out?
Yes.
Go ahead and multiply these two numbers, 0.025 times 16,000, and tell me the result.
400.
400. Do you see 400 listed in any of these answers?
No, all I just
No.
see is 10 to the second power.
So the decimal is right here. Do you agree with that?
Yes.
We're moving it to the left until we get a number between 1 and 10. Is 40 between 1 and 10?
No.
Is 4 between 1 and 10?
Yes.
So it's 4.0 times 10. Now, since we moved it this way, that's one way to think about it and figure out the answer, the
That's
exponent. Or you can figure out, go ahead.
Oh, it would just be 2.
That's right.
Okay.
So that's the answer right there.
What would be the other way? What would be the other way of finding it?
Say that again.
What would be the other way of finding out, or is it just that way?
It's just that way, but I mean, it depends on whether you view the action as being done like when you move the decimal point, or like I look at it as, does my answer get me back to the original?
Oh.
The more you can look ahead to solve the problem, the better you'll be. Okay, so let's try the next one here. Actually, there is an order that's best to do these in, and we're going to do multiplication first. Okay, so we're doing problem 3 next. So the multiplication, if I give you 4 numbers to multiply, like 2 times 3 times 4 times 5, you can actually multiply the 2 and the 4 and the 3 and the 5 and then multiply the answer. You're going to do the same thing here. And I'm gonna be more clear once I get this written out. So you're going to multiply 2.94 times 3.5 with your calculator. So go ahead and do that.
Okay.
10.29. Now you're going to multiply 10 to the 4th times 10 to the 5th, but you're not going to use your calculator. When the bases are the same, what do you do with the exponents when you're multiplying? So 4 plus 5 is 9. Is this number in scientific notation? To decide that, is this number right here between 1 and 10?
No.
No, it's not. So forget about the 10 to the 9th for a moment. How do you rewrite 10.29 into scientific notation? Well, you have to move the decimal. Now let's say you can't remember. Let's say you move it this way. Is this number between 1 and 10, 102.9?
No.
No. Well, that's the wrong way to go. But if you go this way, 1.029 is between 1 and 10. Now, is it positive 1 or negative 1 here? How do you go back? How do you take this and go back to 10.29?
You just reverse it.
So it's positive 1.
Yes.
Now bring this down now.
So this would be 1 plus 9 is 10.
So 10 to the 10. Is that answer there?
I can't see.
Oh, I'm sorry. You don't have you don't have this one. Yeah, it's letter B.
Yeah.
All right. So let's go back to do number 2. Usually you get a big worksheet on these. I'm seeing some of the things with this online system that I don't like because they're not giving you enough practice with them. Okay, so when you divide scientific notation, usually it's written in a form like this: 8.1 times 10 to the 15th, fraction bar 1 times 10 to the 8th. Now this should look like problems we previously did. This is a problem, and this is a problem, or part of the problem. What is 8.1 divided by 1?
8.1.
When the bases are the same and you're dividing, what do you do with the exponents?
Subtract.
Okay, what does that become?
-7. I mean, sorry, 7.
15 minus 8. Sometimes you have to write it out, okay?
Yeah.
All right, so we're up to question 4. then 5, these are story problems, word problems. These are using scientific notation, and you're probably making some sort of a step, like either multiplying or dividing. We'll see what it says here. There are 6.02 times 10 to the 23rd atoms in 1 gram of hydrogen. How many atoms are there in 800 grams of hydrogen?
So you're gonna have to multiply 6.02 and 800 together.
Times 800. Is that what you said? Yeah. Now, the best way to do it is to convert this number on the right here into scientific notation. It's not currently in scientific notation. So I want you to do that for me. I want you to tell me what 800 is in scientific notation.
800 times 10 to the power of 2. I mean 8 times 10 to the power of 2.
Good. So just like we did in the previous problem, we're going to multiply 6.02 times 8, and that's 48.16. Then we're going to multiply 10 to the 23rd times 10 squared. What is that?
That's going to be 10 to the 25 power.
Good. Is 48.116, is it a number between 1 and 10?
No.
No. So we need to move the decimal. So it becomes 4.816. We move the decimal left, times 10 to what power? 10 to what power gets us back to 48.16?
25.
Forget about this. That's coming down. Just this number right here. 1.
1.
Times 10 to the 25. 4.816 times 10 to the 26 power.
Yes.
Now, it looks like they rounded here. I don't know why they do that, but they probably borrowed this problem from a chemistry class where they were worrying about significant digits.
Oh.
Suppose a sheet of 100 stamps is 0.77 millimeters thick. If a stack contains 100,000 stamps, how many millimeters thick is the stack?
Okay. So we need to use 0.77 times.
So I'm actually a little bit unsure here because I suppose a sheet of 100 stamps.
Well, did I get this right or wrong?
I don't know. That's why you have to keep track of your old grades. So, did you take a picture of this?
No, I didn't.
So the problem is it may not be possible to go and look at a previous attempt currently. Let's see if I can find that here. I'm opening it up trying to see if I can get your previous attempt. Nope, doesn't show your previous attempt. All right, suppose a sheet of 100 stamps is 0.77 millimeters thick. So they're saying that for every 100 stamps, it's 0.77 millimeters thick. So if we divide that by 100, that'll tell you how thick it is for one stamp, and then we can multiply by 100,000 stamps.
Okay.
I mean, so that's somewhat reasonable. This isn't quite a scientific notation problem. You can calculate, you can get rid of that zero and that zero, that zero and that zero. So it's 0.77 times, and this right here, 1,000. Actually, let's just keep going this way. So when you multiply by 1,000, you're moving the decimal point 3 places. So 1, 2, 3. So the answer is 770. I want you to convert this to scientific notation.
Okay. That would be 7.70 or 7.7 to times 10 to the power of 2.
Good. All right. So let me enter that, and we'll submit the answers, and we'll see what happens here. All right, so full mark on that. All right, one more lesson, and then we'll move to the quiz.
Okay.
Fractional exponents. These are, I'm looking at these questions.
And I believe I got a
well, the problem is all these can be done with a calculator, so I'm not sure what this is the problem with these systems. I don't know what they're trying to emphasize. So your calculator though may not do it, so that could be an issue. I don't know. No, you're not using a phone. So this is called exponent form, and it moves between back and forth between what's called radical form.
Yes.
So there's the nth root of some number. I'm going to call it x to the m power. This equals x to the m over n. So what you have to remember here is that n is on the bottom. So like, for example, you've seen this in your life. You've seen x to the 1/2 power. Well, this is the second root of x to the power of 1, more commonly written like this. So what I used to do, and I think this is pretty helpful, is I used to have to remember an example. I have to remember that like x to the 1/3 power meant the cube root of x to the power of 1. And I would write this down, or I'd say, okay, that three goes there, and that 1 goes there. And that's how I would remember it. I would come up with an example here. So this problem is the third root, or the cube root, of 1331 to the power of 1. Now the power of 1 doesn't mean anything here, but that's what it is. So you got some options here, like what is it? Well, there's some answers that are kind of unreasonable. You're looking for three numbers that multiply together to give you 1331, so it can't be bigger. And this number looks like it's the division of 1331, so it's definitely 11. So go ahead, if you've got a calculator, do 11 times 11 times 11, and you should see that that's 1331. Do you have that?
Yep.
Okay. All right, on to the next question. So the same principle applies here. Like, we can write this as the cube root of 27 to the 4th power. Okay, but this is not simpler. This is maybe more complicated. Would you agree with that?
Yes.
So 27 is really in parentheses, and 27 can be rewritten as a base to an exponent. So for example, 27 is really 3 cubed. What is the rule when you have an exponent to an exponent?
You would
I can't hear you.
You would multiply.
Very good. What is 3, this 3, the exponent times 4/3?
So that would be 4.
So that replaces this one. So this becomes 3 to the 4th. What is 3 to the 4th?
81.
81. All right, so question 3 looks like some story questions. It also does kind of look like you're starting halfway through this class, which I still don't understand, but okay. This question, you can read it. You've already read it once. They're telling you that m is 243.
Yes.
So what you're trying to do is figure out what is 17 times 243 to the power of 4/5. We haven't looked at this yet, but this is really order of operations. there's multiplication and an exponent. Which comes first, the multiplication or the exponent? I'm sorry, I didn't hear you. Exponents. So the 17 just ignore. We need to figure out what is 243 times 4 to the 5th. So the first thing you're going to do is figure out what is 243. And again, it can be written as a base to an exponent. This one I wouldn't necessarily expect you to know right away. I don't know if your book covered some of these, but it is 3 to the 5th. So now what's the rule when you have an exponent to an exponent?
You multiply.
So what is 5 times 4/5? Still can't hear you. You got to speak up.
4.
So it's 3 to the 4th. So again, what do you do first? Multiplication or the exponent?
Exponent.
Exponent. What is 3 to the 4th?
81.
81. And then 17 times 81 is 810 plus 567. So it looks like it's probably this one here, 1377.
Yep.
All right. So I don't know. They snuck in a story problem in there. That's interesting. I guess. Okay. Question 4 here. All variables represent, okay, so they want you to simplify this thing. Wow, I can see how this would be very kind of overwhelming. It's really 2 questions. It's really, or 2 parts. It's like do this one over here in the box, and then do this one. So let's do the one in the first box. You got a to the 6th, b to the 1/2 to the power of 6. What does this exponent on the outside apply to?
Multiplying.
Both of these, right?
Yes.
So that's a to the 36 times b to the 3rd. Is there another way to rewrite what's in the box on the right here? There is. The fraction. So this number on the inside goes to the top. This number on the outside goes to the bottom. What is 6 divided by 6?
1.
So this is b to the 1, a to the 36 times b cubed, a to the 36 times b to the 4th power.
Wow, I didn't think about that.
Well, you got this right before. I mean, did you guess or did you?
Oh, no. I just went back to my notes and there was a problem that was like this, so I followed it.
Okay, try to do this problem here on your own and let me know when you're done. It's very, very similar. There's really a 2 out here, just in case you didn't remember that. It's very, very similar to the last one.
Then they didn't add that. That's why I got it. X to the power 2 and y to the power 2.
Say that one more time.
X to the power 2 and y to the power 2.
Okay, so let's look at this part in the box first here. So x squared, y to the 4th, y to the 4th, 1/2. When you apply this exponent, what's the result?
You're going to get x to the power 1 and y to the power 2.
Okay, so this on the right here is x. The 4 goes up top, the 2 goes on the bottom. So what does that reduce to?
2.
So did you get to this point?
I got to that point and messed it up. I just did the opposite. I did 2 over 4 instead of.
No, you didn't do that because that's not an answer. So it's 1 plus 2 is x cubed, y squared.
No, where it says there x, well, x to the power 1, y to the power 2 times x, I flipped the numerator and denominator. I
All right.
flipped it, so that's why I did that.
Okay, so we're going to move to your quiz,
Okay.
and we're going to see. Well, this will be my first chance to see what you've got here. All right, I guess I got to find it under modules. I wonder how many questions it is.
I believe there's 10 or 5.
All right, 10 questions. No time limit. Well, what's interesting is the first question is nothing close to what you did previous. So, all right. All right. So first question here, 64 to the 1/3 power plus 16 to the 1/2 power. Probably best if we rewrite this. This is the cube root of 64 plus the square root of 16. So you're trying to find 4 numbers that multiply to 64, or 3 numbers that multiply to 64. What would that be?
4.
4, good. And then the square root of 16 is?
4.
So what's your answer?
8.
All right. So the next one I want you to try on your own. It's like one that we did just in the last, hour. If you've been taking notes, they would be good to look at them. Although this one actually it's interesting. This one's different than the ones that you did. So actually, it'll be better if we do this together. So this is 2.35 times 10 to the 13th fraction bar 5 times 10 to the 6th. Do you remember us doing that together?
Yes.
Okay, so grab your calculator and divide this number here.
Okay. I get 0.47.
Good. And what goes here? You've got a 13 up top, a 6 on the bottom. You're dividing. So what do you do with the exponents? What's the math operation? 13 minus 6. Notice I write it. Even though I know the answer, maybe you know the answer, I'm writing it so that I don't forget that it's positive. Is this number between 1 and 10?
Yes.
It is?
Oh, no. No, it's not.
Okay, so this is what's different is you now have to make this number 0.47
scientific.
So this time the decimal's going to the right. It becomes 4.7 times 10. Don't forget about this. We're gonna bring that down, but we're just looking at the 0.47. We moved it to the right this time. This is what's different. This becomes -1. Do you see that? Because -1 moves it back that way.
Hmm.
Now, when the bases are the same and you're multiplying, what do you do with the exponents?
You subtract the exponents.
I'm sorry, what?
You would add the exponents.
You said subtract. Now you said add. Which one is it and why?
It's add because we're not dividing, we're multiplying.
So it's -1 plus 7. So when you say add, you're just putting that operator in there. Like you don't change the numbers. What is -1 plus 7?
6.
No yawning. All right, we're up to question 3. I'm going to snip this in. Okay, so when we worked on a problem like this before, I said, well, sometimes you can evaluate what's inside the parentheses. This time, that's not possible because there's nothing to do inside there. Do you agree with that? Okay, so what did we do when we had a negative exponent and a thing on top and a thing on bottom? What did it become? I can't hear you.
We would flip the numerator and denominator.
That's right. And rewrite as to the power of 4. Now, this 4 goes to everything. So it goes to the 4, the power of 1, the power of 1. So what's up top? What is the new exponent?
Y to the power of 64. Oh, 16, 16.
Why did you get 64?
Sorry, sorry, I was thinking.
Don't apologize. I want to know why, because that's why you're not doing well in this class. Is there's something that's not clear?
No,
What
I
about
was
on the
just.
bottom?
Oh, 8.
What? What?
X.
No, Christopher, it's 2 to the power of 1. You're multiplying the exponents.
2 to the power of 4.
And what about x?
X to the power of 4.
Okay. Now, if you didn't know any better, you could just say it's a because it's got the right y to the 16th, but we're going to go beyond that. What is 2 to the 4th?
2 to the 4th is 16.
All right, so now you see why it's a. All right, they kind of give you a vanilla next question here. All right, so see if you can do this one on your own, please.
To the power of 2.
17 to the power of 2. Very good. Stand by for a second here. I got to log something. All right. Okay, 17 to the power of 2. All right, we're up to question 5. So question 5 is a little bit more difficult than a little bit more challenging than the one we just did, but not all questions are created equal. Okay, so we did one like this. It's really 3 separate parts: 9 over 81, a to the 5th, a to the negative 6, b to the 5th, b squared. So we just got to tackle each of these. Okay, 9 divided by 81. Do not say 9. 9 divided by 81.
Is 1/2.
I'm sorry?
Is
A half. Um, so if I take a half and I multiply it by 9 over 9, I get 9 over 18. Is that the same as this? I can't hear you.
1/9.
1/9. Good. So that's 1/9. When the bases are the same and you're dividing, what do you do with the exponents?
You subtract them.
Okay, now this is very critical, Christopher. 5 minus, because you're subtracting,
You put
negative.
parentheses.
Yes. So what does the exponent become?
It would be 11.
Okay. What about over here?
It would just be 5 minus 2, which is 3.
Okay. So based on what you see here, it's a to the 11th, b cubed over 9. So which is the correct answer?
The third one.
The third one. 1, 2, 3. None of these?
Oh, sorry, fifth one.
Okay. So you're at a huge disadvantage, Christopher, and like you not only have to get the problem right, you have to select the right answer. You notice like you could have done this problem completely correctly and entered the wrong answer, and someone might think that you didn't know how to do it because you entered the wrong answer. So this time we're going to look at what's inside parentheses. You got a 4, x to the 9th, x to the 5th. That y to the 5th is still on the bottom, so you have to write it this way: 1 over all to the power of 3. So let's evaluate this x to the 9th over x to the 5th first. What is that?
Sorry, can you say that again?
What is this middle? What is this middle one that I boxed in?
Oh, x 9 minus 5 equals 4.
Okay. So this is where we're at so far. So then we're going to combine, we're kind of squeeze everything together. 4x to the 4th over y to the 5th to the power of 3.
Mhm.
So there's a power of 1 with the 4. Do you see that?
Yes.
So this 3 applies to the exponent, not the base. The exponent, not the base. 4 is the base, 1 is the exponent.
Mhm.
So what does this become?
4 to the x to the power of 12, y to the power of 15.
Very good. So which is the correct answer?
So 16 times 4 equals 64. X to the 12 and y to the 15th. So it would be the third one.
Letter C, often said.
It's
Okay.
just about number 3.
Oh, here's a good one. So this one is very much like the one we did. It's really similar. So I'm going to snip it in, and you're going to be able to do this. Okay. I'm going to stand by, and you're going to tell me the correct answer.
Okay. It's the second dot, or letter B.
I'm just checking you here because I haven't actually worked through this. So the eighths come first. Okay, least to greatest. Then the middle one. Yep, looks like it's letter B. Good. So that's nice. I mean, it's nice when you get one that's like a really similar match to it. One of the things I don't necessarily like about this quiz is that there's the answers are just or the questions are all there's no like increasing order of difficulty. They're covering all the topics. So you just sort of have to you really have to know everything to be able to do it. So this right here, you didn't see anything like this. There's so many variations on the problems that they probably can't give you an example of every one. But this 4 out here, this exponent needs to be applied first.
Yes.
Okay, so what's the exponent of p and q inside here currently before you apply the 4?
It's just p to the power 1 and q to the power 1.
Okay, so after you apply that exponent on the outside, what does the bottom become?
P to the power 4 and q to the power 4.
Okay, so this is a problem that I'm putting in the rectangle, and then the one over here is also a rectangle. So p to the 4th,
Is
p
1.
to that's right. It's p to the 0, and then over here it's 3 minus 4. What is 3 minus 4?
Negative 1.
Negative 1. So this is 1. You just told me. What is q to the minus 1?
1 over q.
So what's the correct answer?
The second dot.
Good. All right, so almost there. 2 more questions, I think. Why is this method of, why do you feel like you're getting more out of this than you normally do?
What do you mean?
Well, it seems like your understanding's greater.
I don't know. I think it's just because just somebody to teach me or show me how to do it is better than
Very,
videos or stuff.
all right, this is one you did already. It was the last question or second to last question on one of the previous assignments.
Yes.
So go ahead and try this one on your own
Okay.
and see if you can get the right answer.
It's the last dot.
Okay. How did you come up with that?
So first I would, for the square root, I would put b 9/9
Good.
first.
That becomes b to the power of 1.
Yeah, so I would leave it alone first, and then I would go to the parentheses first and use the exponent, what do you call it? The exponent outside the parentheses and multiply it into both a and b.
Good. All right, you got it. You understood it as well. When you can explain it, you definitely understand it. All right, last question here. I'm going to ask you to do this one on your own because it's something we've already done, and I don't see any reason why you can't do it. So um, let me know when you get the right answer, please. And if you're guessing, let me know because I don't want you to guess. Guessing creates false understanding.
Is the first one?
Say that again.
It's the first one.
Okay, so we're going to write the number. This -3 either means you're going 3 left or 3 right. Based on what you told me, you went 3 right. It's actually 3 left. 1, 2, 3.
Wait, what?
Well, it's negative.
That's
Negative exponents indicate that it's a small number. Small meaning like less than 1. Positive exponents indicate that it's a large number, bigger than 1.
yeah, but wait. Oh, never mind.
So based on this, what is the correct answer?
0.00131.
Okay, so which letter should I choose?
Letter C. C.
Very good. Okay, so I'm just going to check here that all the questions were answered. I believe they are. 1, 2, 3, 4. So you should always do this. Like, actually, well, I don't want to show that screen. If you don't check, it's not the instructor's fault if you didn't answer a question. It's your fault that you didn't answer. Now, lots of things can happen. Like you can have miss accidentally touch the screen or whatever, but you at least need to answer every question. All right, questions submitted. Okay, so that ends the lesson for today. And I'm going to try something new here. Just a reminder to subscribe to my YouTube channel, and I'll send out the notes and the screen sharing here shortly.
All right.
Thank you very much. See you next time.